Hello. We're excited to have you join us today for our webinar on how to get started integrating CI/CD pipelines into network automation and orchestration. Before we get started, my name's Morgan Stern. I'm the VP of Automation Strategy at Itential, and I'm joined today by Jackson Flores, who's a Senior Solution Engineer for Itential. How are you doing today, Jackson?
Good, Morgan. How are you doing? I am
Doing
very
great.
excited to be here to discuss how we can help our customers through their NetDevOps journey.
Excellent. All right. So during today's webinar, we're going to describe how networking teams can begin to incorporate DevOps principles and CI/CD tooling alongside their network automation and orchestration tools. If you have any questions, please ask them along the way in the chat window, and we will answer them in chat. So let's go ahead and get started. One of the things I wanted to start with was to really explain the kind of different focus between some of the previous sessions and this session. In the last session, our primary focus was around application developers whose job was to deploy new applications and they needed access to networking services. So they're doing merge requests and testing, they're doing approval state, they're doing all those pieces, but in their previous model, they would do their piece and then they would get stuck waiting for the networking teams to do their job. And so we focused on how can we use tools like the Itential platform to expose network services to that application developer community. Today's session, we've got a different focus. Today, we're really focused on the networking engineer whose primary job is to continue to deploy network changes. And so here, the focus is explaining for those network engineers, how can they start to get benefit by starting to phase in utilization of DevOps tooling and practices, CI/CD pipeline components, and other methods that generally roll up under the network infrastructure as code model. So with that in mind, let's talk about where we're at. When you think about the CI/CD process that's evolved, I mean, generally people think about the same set of phases. And the whole purpose for this process was really to create a predictable, consistent, automated process that would get away from the old model of doing very monolithic, infrequent application changes to be this model of continuous integration, meaning I'm going to, as I make small incremental changes to the code base, I will automate the testing and build process such that we can have better outcomes. We can identify bugs sooner. We can basically get better velocity around being able to implement smaller changes more quickly. Now, when we start to think about how do we take this CI/CD and DevOps philosophy and apply it to networking, it can be a little bit intimidating thing, right? Network engineers look at this and say, man, there's a lot of components. This is a very complicated process. How can I get started? And so today's session, we're going to focus on a couple of areas as well as a phased approach for how to leverage all of the benefits of a DevOps model, meaning I'm going to be able to do more changes more frequently. I'm going to be able to benefit from having a test environment and a test model that happens prior to production. I'm going to benefit from having a consistent, reliable approval and deployment model, all of those kinds of benefits. So to do this, the first thing that we need to be clear on is when we take a model that was developed for application deployment and we apply it to networking changes, what are the things that we can take completely versus what are the things that maybe require some adjustments? And in some of our previous webinars, we identified three key areas in the CI/CD model. First was around what's listed as payload generation. In the software world, payload generation is about a developer who is writing an application, right? The payload is the code. The code goes through the pipeline, goes through all of the processes, gets tested, gets deployed, gets monitored. That's different in the networking space where network engineers are creating configurations. And in a manual world, they're doing this by hand. And the configuration will be some combination of the specific syntax that's required from the network devices, as well as variables that are unique to the specific change that the engineer team needs to make. Could be I've got to change addresses, I've got to reassign VLANs, but it's some combination of understanding, okay, what is the syntax required from the system for me to do this, and then what are the pieces I need to do. So that is one stage that's very different. Second would be around testing. In the software testing model, there's a consistent approach for doing unit testing, integration testing, system testing. Unfortunately, in the networking world, uh, in most environments, the testing happens as part of the production rollout. So teams will build very comprehensive pre-check and post-check processes so that they can make sure that any change that they apply to the network doesn't have an unintended outcome, meaning it creates a problem or doesn't fix the problem it was intended to fix, as well as then they've got to develop rather elaborate rollback procedures in the case of a particular operation not being applied successfully. For deployment, there are a whole set of continuous deployment tools to accelerate the deployment of applications. Most of the time in the network world, engineers will need to log in to a CLI or they're going to run a script. They're going to do those pre and post checks. And one of the major differences, I think, in this part of the overall process between applications and networking is a lot of times networking changes, things like order of operations are critical, particularly if you're making a change across multiple systems, that you need to do things in a specific order to get the appropriate outcome. And if you try to apply things just as one big block of config change, that can sometimes result in an unsuccessful change window. So what we have now is this fusion of network operations and DevOps. People are calling it NetDevOps. Our thinking around this is NetDevOps is moving away from the traditional network operations model of I'm going to test in production. I'm going to have very robust procedures based around that production piece. But by the time you're doing that testing, you're very far down the process. And so NetDevOps is really being able to take advantage of CI/CD, take advantage of infrastructure as code, other DevOps principles, so that I can move a lot of that risk away from the production network. I can move it earlier in the stages, and I can do that because I can use the tools to automate the things that would normally take a lot of time, like testing. One of the reason people don't test in the network world prior to production is because it's complicated to do. It requires environments to be set up a specific way, and all of that entails a lot of work. But if we can automate that, and if we can leverage a lot of the testing frameworks that already exist, that eliminates all of that extra work, which means now I can have an environment that looks closer to my production network that will be a valid environment to do testing in. Once I do that, and once I start to automate those activities that are really time intensive, I don't have to think about scheduling major changes. I can start to do smaller, more incremental changes because I've built in that test environment. I have been able to grow a test set over time, and I can start to introduce changes not just in these sort of big chunk windows, but start to introduce them more quickly. When we look at the DevOps world and we think about how do I do this in some kind of a phased model, one of the things that we've found useful is to think about the different components of most DevOps or CI/CD environments. And so here we've identified four systems. In the previous session, I think we talked about another kind of function as well, and I'll mention that briefly. But the key four would be the repository, which would be like a GitHub, where its function is to provide storage and version management of the files. In the software world, that would be the application code. Here, we're going to use that same infrastructure to manage the configuration files. And that gives us the ability to track changes, to do version to do versioning, to do merge requests like you would with an application, and to have that repository exist over time so that at any point in time I can use that as one of my sources of truth to be able to manage the network. Second component would be the pipeline, right? And under the covers, pipelines are generally script based, but the intent of the pipeline is to define stages like build, like test, like deploy, and to be able to utilize that technology to have a very reproducible, consistent process for all of the steps of the phase. So once testing is done, now I can automate the approval process to be able to get the input from the appropriate stakeholders. And I don't have to use email. I don't have to use tickets. I can just use the pipeline to manage all of those pieces and to keep track of where any given changes in the process. Another category of components would be test systems. So these would be software, in some cases for networking. There's hardware around doing testing, but more and more folks are moving to virtualized components for that. But that's any kind of system that you would use for either doing like testing of the semantics of the text, or to actually use to like create test loads to test certain changes to your configurations. And then here we've listed the automator, network orchestrator, and this is, I think, one of the most appropriate places where like network automation tools and orchestration tools can intersect with the CI/CD tooling. Meaning, for the software developer, I'm using my development environment to write code. Well, to do those kinds of payload generation, it is a much simpler process for me to start to leverage the network automation tooling, because it's got the capability to do scripts. It's got the capability to go out and get information from the network or from sources of truth. I can generate those configuration changes much faster, much more consistently by using the network automation platform. And I can use that to manage those parts of the deployment that have very high sensitivities to order of operations. So things like pre-checks and post-checks are far more efficient if I'm running those through the network automation platform than if somebody is doing them manually. So when we think about these components, let's talk about now really like how do we phase this in? The model you see here, everything in blue, is pretty much the manual model, right? The four major phases we've identified here is around creating the payload, doing the testing, doing the deployment, and then operating the network after the change has been made. And so here, typically, this is like ground zero for where people get started. So they don't have many tools. Most of the documentation is like document based, meaning they might have information in spreadsheets. They might have information on their laptop or on their computer. But generally, people are doing things almost on paper. So in some situations, vendors will provide guidance around how to configure a specific function or feature or capability. Some folks in the engineering team will develop a process around how do I create the specific configurations for what I need. Once that configuration is made, then it gets handed off to some engineers whose job it is to do the testing. And if they have a lab, they can start to test the changes there. Otherwise, it really becomes like linked to the deployment process, which would be a handoff to the team, either operations or someone else who's responsible for the production network. They may schedule a maintenance window to make the change. They deploy it on the network. They run pre-checks and post-checks. Once that's done, they signal to the operations team, change is done. You can monitor the network and go from there. Now, how do you get from here to something that looks more like the CI/CD continuum? One of the ways to do that is to start to strategically implement some of the tooling and process uh, that is going to be leveraging like DevOps principles into this process. So here, where you see now, instead of just all blue, we've got some combination of green and blue in some of the stages. All that is intended to represent is situations where I'm starting to leverage tooling. So here, one possible way to get started is let me introduce some capabilities around automating the pre-deployment testing, meaning I'm not going to sit down and go through a Word document of doing steps to do a pre-check and post-check. I'm going to embed those in code. That becomes most critical in the deployment phase. I'm also going to start to introduce other automations for the deployment team and the operations team. And what I'm going to do is I'm going to link them together by implementing a repository for doing version control. So now I've got this ability to track every change that happens that becomes an asset for the deployment teams in the event that they need to roll back. It also becomes an asset for the operations team so that they can have visibility to changes, not only the fact that a change happened, but exactly what changed happened. They can roll back if needed. They can do root cause analysis. A lot of benefits just by making that transition to a repository and starting to leverage some of the automation tools to eliminate those activities that are they're high sources of toil. Right. In this phase, most of the benefits are really happening at the engineer level. Like an individual will be able to do their job more efficiently. But because we still have manual handoffs, there isn't a whole lot of efficiency that's gained from like the end-to-end process execution. So then what we start to do is think about what can we do to tie together these steps so that we can eliminate those sort of bridge points between where people are using tools. And I can leverage additional tools to do that, specifically things like pipelines. So in this what we're calling final phase, right? We may have jumped a couple of steps, but what we're calling final phase here is now I have taken advantage of NetDevOps principles, of network automation orchestration tools across the way. So that instead of the vendor just giving me a sample of a configuration, maybe with some instructions on how to activate a particular feature, they can provide templates that I can immediately ingest into my system. Engineers can then modify those templates. They can develop workflows instead of writing Word document processes for making the changes. And once they've decided that a change is ready to go, they can leverage a pipeline to basically to trigger this entire process. So pipeline gets the merge request from the engineers that immediately triggers test activities. The test pipeline will, appropriate to whatever the payload is, they can generate a test environment, they can run test cases, they can do a lot of validation of the code to make sure that it is accurate and appropriate for what needs to happen. If needed during this stage, the engineers can also develop some additional workflows that will be then leveraged by the deployment team. So once testing gets done, the merge gets approved, it then gets triggered to deployment. The deployment team can take advantage of all of the assets that were created in the steps prior. So they don't need to create anything new. They can continue to use the repo, for example, to be the source and version control. And then once they're done, it's just handed off to operations. So the key thing here is like pipelines are really good at maintaining consistency of process and around building more and more robust stages. How you then execute within the stage becomes a matter of deciding, okay, what's going to be the tooling that's most appropriate in this stage. Now here, unlike in the previous slide, here the benefits are multiple. We do have all of those accelerators for the engineers, but we're also being able to introduce changes in a much more rapid pace because I've eliminated all that idle time in between steps. And because I have created a system that is focused on a consistent, repeatable process, the outcomes are going to be much more accurate and much more effective. So what we see in a lot of cases, the more that things are relegated to manual typing, to documents cut and pasting, there's a lot of room for errors to get introduced into the process. By moving towards this, we eliminate all of those gaps. So people aren't cutting and pasting, people aren't typing in manual errors. We've done now multiple rounds of testing. So it really eliminates the risk on deployment side of, okay, if there's a an error in one of the pieces of code, if there's a typographical error or anything else, we will have caught that well before it gets deployed, meaning I'm eliminating a lot of risk on the network. So to demonstrate one example of this, I'm going to hand things over to Jackson shortly. The focus of this demo is the front end of that process of how can I then start to leverage some of the tools and capabilities and processes that we've talked about with a focus around enhancing the testing and building phases of the process. So Jackson, I'm going to hand things over to you.
Thanks, Morgan. In my experience as a network engineer, I have seen this process of changing configuration standards many, many, many times. I was part of providing the configuration templates from the vendor standpoint as a network architect and engineer for many years, working with a vendor. And in the best case scenario, what I've seen is customers will store, as you were referring to earlier, Morgan, their configurations in a central repository that can do some sort of version control. Then they will check it out, make a modification to it, perhaps do some testing if they can. In some instances, as you were referring to, they will test in a production environment and post validate after the changes are done, make sure that we didn't break anything. And then they notify the operators to consume those changes and deploy into the actual network when those use cases come in. Worst case scenario, this is handled, as you were mentioned before, also in a hand-to-hand document, right? Excel sheets, text paths that get passed on over email or a link to a repo somewhere. Oftentimes, this is a big challenge because this leads to the operators having potentially outdated templates when they don't get notified that the template changed. And sometimes they're working on 2 to 3 weeks old or days old templates. And this is especially troublesome when the changes that we're making to those templates are done to handle security vulnerabilities or things like bugs and that kind of thing. This is where we think that a NetDevOps approach can be really, really useful. The purpose of the demo today is to showcase how Itential, with its rich orchestration ecosystem and integrations, can help be integrated as part of that CI/CD process to get started in that journey towards NetDevOps. Here we have a demo overview, and what we're going to show is an engineer making changes to that configuration template standard and submitting it through a change process, but from the standpoint of a NetDevOps process. So we're going to be creating a new branch of configuration and treating configuration almost as code from that perspective in our CI repo. Then the next step is we're going to deploy assets triggered via pipeline, but utilizing Itential's rich integration and functionality with tools like GitLab and so forth to deploy those assets into an Itential development environment where we have access to equipment and we can actually launch those configurations and test them in a secure and safe environment. And we can perform validation, make sure that it all passes through, syntax is correct, and so forth. Then we'll perform some cleanup on that lab. We will clean up after ourselves, right? Remove that configuration. And then we will execute a merge into our master branch, which is the equivalent to what our production golden templates are from the CI standpoint. And from there, we were going to take a second stage where we actually automate the deployment of those assets into our production environment for the operators to consume. And we will show that last piece by showing the update and how the operators can actually see it and do a dry run on those configurations. I'll switch over to my demo screen now. Okay. In the last webinar of this series, Dan Sullivan, my colleague, was demonstrating how he was leveraging Itential to create a set of discrete automations that can be launched from CI pipelines. In this demo, we're going to follow a very similar model where we're going to show beforehand, I'm going to show you some assets and automations that we have created that are very target to perform a very targeted process on either a network device and perform some testing, render configuration, and so forth, or to perform some asset manipulation and so forth. In my screen, I have my Itential automation platform as well as my Visual Studio Code that I'm sharing. I'm going to hide that for now so that it's not distracting. For those of you that are frequent attendants of the webinars, you're familiar with this. And for our customers, you're familiar with this screen. This is our Automation Studio screen. And for those of you that are new, this is the Automation Studio application where we design and build all the automations from the Itential automation on the Itential automation platform. The first asset that we will be leveraging on this demo are our command templates. Command templates are a very useful tool that allows engineers to very quickly and rapidly design pre and post checks that can be executed on devices and actually evaluate rules against them. In this command template, I have a very basic list of commands that I have created to validate our configuration template, where I am checking some interface status, some status on my underlay routing, multicast, and so forth, and including things like BGP that I'm actually going to be affecting during this demo. This command templates are especially useful because they allow the introduction of rules into them, where I can actually have contains statements or do not contains, or even fancier with regex, where I can say, hey, I want to execute a show IP and brief on this Cisco device to show my interfaces and their status, and I want to make sure that my Gigabit Ethernet 1 interface exists. This is a very menial example. In this case, I'm using a virtual router, so of course that interface exists, but it showcases the power of the platform. And I can actually execute tests of those commands in here as well, just to make sure that they're all valid. Another asset that we're going to be testing, and in this case, it's actually an automation workflow that we will be exposing through our operations manager. And I will show how that's exposed in a second through API so that they can be consumed, is this workflow. The purpose of this workflow, very simple, a handful of tasks. And what this workflow does is it leverages the GitLab integration in order to pull those assets, those configuration template assets that I have developed through my CI process in order to keep my development environment updated and perform tests on them. So we have 3 steps total that all the major ones affecting this is: one is getting the file template, the Jinja 2 template. For those of you that are not familiar, Jinja 2 is a templating language fairly common in the industry that's used to render device configurations. Then we will get a sample payload that we store with our CI template as well at the same time. Then we will transform that data. This is another very powerful piece, and we can actually have a look at this once we run the processes. We have the ability to take those outputs from our API calls to GitLab, which are very sizable APIs, I might add, the results of them at least. And we can transform them in such a way that we can pass them to another task in order to pass those templates into IAP in a way that Itential automation platform understands them. And we can do this for several integrations, and we will show that also as we go along. And then the final asset that I'm going to show is this automation asset that we have here, which is another workflow. And this is the actual workflow that's doing the testing. As you can see, it's a little bit more complex, but not that much more complex than the previous one. What we're doing here is we're importing a sample payload again that we're going to use in our lab environment to test the rendering of our configuration. Then we will render that configuration template. Again, we're performing a transformation to make sure that we convert that config template into something that we can pass to our automation gateway that will configure an actual lab device in our lab environment. From there, we corroborate that configuration change went through. We execute some post checks commands, transform the data again in such a way that I can actually use it for logging as well as sending email notifications. So in these two tasks in here, I actually have an email that I will get at the end of the process because it is a fully automated process. I will get emails with logs of how those outputs look like for those changes that I made. And if it errors out, I will also get another email as well. And we will lastly perform a little cleanup where we're going to revert those changes in the lab to make sure that the next time we execute a test, it wasn't affected by what we did. I mentioned previously that we have our operations manager, which allows us to expose these automations through APIs. And note the title or the name of this automation workflow, because that's what we're going to look at on the operations manager screen. As you can see here in my operations manager, I can actually create an entry that I can point to that workflow that I was looking at before, and I can actually create a trigger. And if I click on this trigger here, I can actually look at the properties, and now it allows me to see that this trigger, I can define it as an API endpoint to our automation platform where I can create a custom route. And this is what I'm actually going to use from my GitLab in order to trigger this automation to run, and I will give it some parameters that it needs to run. Without further ado, let's jump straight into it and let's launch this demo and see what it does. Now, one of the things that I will caveat is, along as we go through the pipeline, I actually had to add some pauses and manual steps to trigger the pipeline just to make sure that we can actually appreciate the changes, because otherwise it goes too fast and it's very difficult to explain at the same time it's going. I'm going to verify in my Visual Studio Code. What I have here is actually opened up my repository of configuration templates. So I have done a Git clone. I'm using GitLab as my Git repository. I have cloned my configuration repo into my laptop, and I'm actually opened it up with Visual Studio Code, very useful tool for doing this kind of change. And what I will do is I'm actually going to edit this template. But first, I'm going to check that I'm on my actual branch that I want to be on. So I'm on my dev branch. As part of the demo, I want to execute, test it with the pipeline, and then merge it into master. So I want to make sure that I'm on my dev branch. So we're here. Everything is good. Now I have a pre-created set of changes that I will paste on my configuration here. And what I am doing is actually I'm augmenting my BGP configuration to now add BGP neighbors along with its respective parameters into my configuration template. And to support this, I have a sample payload that I have already pre-created, and we will be rendering this sample neighboring here, which is going to use this data. From here on, I checked out my template looks good. My syntax highlighting looks good. It's not highlighting any errors. So I'm going to move into my commit and merge. So I'm going to put a comment here for my commit, added GP parameters per standard. And I'm going to commit and push this into my dev branch. From here on, I'm going to go into my GitLab. I can see my repo here hasn't changed yet. I'm going to refresh my screen just to make sure that I can see my changes. And you see here that my commit went through. The changes were uploaded just now, and my comments reflected in here. And you can see at the top, I got a merge request now that I can execute because I pushed changes to dev environment. I'm going to create my merge request. I'm going to put some comments in there. I normally just copy my title, and I'm going to uncheck this because I don't want to delete my branch. And everything looks good. And I will create my merge request. As I create my merge request, you will notice here that a pipeline will be launched for this. And once the pipeline gets launched, we can go and start looking at how we're actually calling automations and walking through this whole process. Right now, we're doing a local job in GitLab where we're just taking those configuration templates and performing some basic linting, making sure that our syntax is good. It's all valid. We have a JSON file and a Jinja 2 file, and we will be just performing some basic validation in those two. Next, we're going to perform our step to deploy those changes into our dev environment, and hopefully we can switch over into our ops manager and catch it on time with those delays. And then from there, we will go into our template test job that we looked at earlier and see how the configuration template test is actually being executed. And then we're going to perform some cleanup as well. If I go to my ops manager now and I go to jobs, I should be able to see an active job here at some point. And here it is. So we're walking through, we already went through, and now we actually has a delay where we walk through our entire import process of this template. So you can see that Itential is doing a lot of the heavy lifting here when it comes to actually providing the integration with tools like GitLab and so forth. And we will see more integrations later on. And also the one thing that I wanted to point out is from earlier discussion, these, when we execute calls into GitLab, the outputs are very large and not necessarily in the format that I need them for other tasks to consume. And this is where these transformation tasks come very useful and are very, very, very important for my automations. It will take all these big payloads that are coming from GitLab, and it actually will ingest it in such a way that it creates a template object that I can consume in my automation platform as I go through my import process. Well, let's head back into my pipeline, and I have to refresh this in order to see that the pipeline completed. As I was stating before, we had introduced some manual steps, so we're going to be triggering these as we go through because it is very difficult to capture and discuss through the demo. But one thing I want to call attention to is if I go into this log, it'll actually show us how easy it is to consume those operations manager APIs that we were looking at before. If you look at this portion here specifically, this is the most important one in my mind. This is where we call Itential to execute that template import, and we give it the parameters that it needs. We say, hey, this is the project, the GitLab project. We have an adapter that has already been pre-configured. An adapter essentially is a piece of software that will add connectivity into GitLab. For this example, we already have pre-configured it with which GitLab account to point to and so forth. So we can just tell it, hey, go grab this project from GitLab. This is the branch that I want to grab those files from, and these are the files that I want to grab from there. So Cisco IOCSR standard J2, which is the one that I made changes to, as well as the JSON file because I want to grab that file in case it changed. And then we can see how we also get some values back as well. This will be more useful and apparent when we go through the testing phase where we will actually see logs from the device. So I'm going to launch that, and I'm going to open it here just for observation. And while that goes through, I am going to go into my operations manager and go back and observe my active jobs. And momentarily here, we should see how we launch a test job where we're going to go and actually take the template that we just imported that wasn't existent into the platform. And we're going to go and actually render the configuration against that template and apply it to an actual lab device. And here we go. I just see the job popped up on my screen, and I'm going to zoom in here. And we already went through and imported the payload, and I can look at it here. This is what the template is expecting as far as payload goes. And we have rendered the template. We can look at how Itential can render configuration templates, as well as doing some data transformation so that all the information from these tasks will be understood by our automation gateway that needs to take charge of actually applying the configuration. And here we can see something that's kind of familiar for those of you that practice networking every day, of course. So we can see the actual configuration change that I submitted along with everything else. So now we have our neighbor BGP statements that we just added. So we're rendering all that config for our sample neighbor. And then we executed some post checks. Those are the commands that we executed. And here we have a log that will be better observed somewhere else. And after that, we do some cleanup steps and so forth. I'm going to go back into my pipeline and show how we called this job from the pipeline itself as demonstrated before. But more importantly, I wanted to show also is the fact that we're able to output logs into the pipeline here in this fashion. So you can see all those show commands that I mentioned before are all logged in the pipeline as part of the process on how the testing. So we render these configurations were part of that change, as well as a couple others. So we have OSPF interfaces, we have multicast interfaces, we have routes captured. Now we know that we activated OSPF and BGP, and we have that neighbor that we rendered earlier. Another thing that I want to show also is the fact that I actually have that output as an email. So this really showcases, in my mind, the power of the Itential automation platform, where we're able to do all these things fairly easily. If you remember that workflow that I walked through before for the testing, it was just a matter of inserting one task and putting that log variable that I had in there, just pointing it to this email task and just send me an email. So now when I'm able to run this process completely automated, I can get my emails next day or 10 minutes later. I can go grab a coffee, come back, and I see my outputs and everything succeeded. And if it would have failed, I would have gotten a failure email. From here on, let's go back to our pipeline and let's refresh this guy. So now we know that that template test completed. We got a good check mark there. It succeeded and everything is good. Everything is happy. So I'm just going to trigger my template delete and we will let that go through. And we will see another job pop up over here. That job goes fairly quickly as well. Maybe I just observe it from here. That way we know when it's finished. This is just a cleanup step for our purposes. So nothing much to get concerned there. Just again, another very simple trigger. We just provide the template ID that we had created. If I go back to my pipeline and now I want to go to my merge request, we can see that our pipeline succeeded completely. And now we're actually ready to merge our changes into production. In a normal CI process, you will go through this and you will actually have an approver that will actually merge these changes, right? In a network environment, like we were pointing out before, and Morgan was pointing out, sometimes we have to test these things in production. Here we have the luxury of being able to actually, in a completely automated fashion, do testing and validate that our syntax and our actual intent is working properly. And then we can say, okay, we authorize that merge. I feel comfortable with this. I'm going to authorize my merge. And this change will actually trigger another pipeline. And this pipeline, essentially what it'll do is it'll actually deploy this change into my production environment. This is actually delayed pipeline, so it'll run in 45 seconds. I think I can actually just play it. There we go. And from here on, when this is finished, I'm going to take my engineering hat off and I'm going to put my operator hat on, and we're going to actually go look at our production environment and see the actual updates being reflected in our operations, in our production environments template. I'm going to bring up a new screen. This time it's actually pointing to my production Itential platform. And I have in my operator view, you can notice here that I have actually far less access to applications. I can see my operations manager where I'm just in charge of executing work. And that's where I was making the analogy of taking my engineering hat off and putting my operator hat on. So now I'm going to just worry and concern myself with making network changes and making sure that now, because all the process is automated, I don't have to worry about going and getting the latest configuration template from the repository or actually go check on my email for changes. I am confident that the configuration template deployed in the production environment is actually the latest. In my ops manager screen, which we have seen before, we actually now, in this case, we have a manual entry. So I will actually run this manually by clicking through and populating my form. My form is pre-populated. The template name is going to be the same as my repository, and it happens to be the same across all my files. My payload source, in this case, I'm just going to use the dummy payload source that we provided straight up from GitLab because I am just performing a dry run in this instance. And this is the payload file name, and we're just going to launch this. This happens to go very quickly. Again, we're just pulling that payload from GitLab. We're rendering that template, transforming it along the way with the power of the JSON schema transformations that Itential brings to the table. And then we're just going to do a little dry run that I want to display here in order to show the changes to the configs that we made. So now this is what my configuration template looks like for this particular payload that I provided. And we can see how our BGP neighbor changes are actually now affecting this configuration template. I'm going to proceed with this change, and that is the end of the demo. Any questions you may have, you may post them in the chat at any time.
Thank you, Jocelyn. That was great. I really appreciate you kind of going through at that level of detail and showing the audience what you can do with that technology. And with that, I think we're gonna wrap things up. Let's see. We're gonna wrap things up. I want to thank you for your attendance, and if we didn't get a chance to answer your question in chat, we will get back to you shortly. And this concludes the session. We will have another session in this CI/CD series coming up at the end of the month, and look forward to seeing you there. So thank you, and take care.